Mm-hmm.
I'll just open. Okay. So yesterday we have started with unit 2 and we had seen correlation.
Mm-hmm.
We have seen
Yeah.
correlation, correlation, and we have seen that correlation generally cannot tell you about the future or the prediction from the graph. Cannot tell,
Mm-hmm.
cannot predict the output, cannot predict the response variable, cannot predict the response variable. Okay.
Mm-hmm.
So now in today's class, we are going to look at some interesting things. Yeah. Okay, we had finished with it. Now that's, I think we must do one question here. Okay. So how does the fuel consumption of a car change as its speed increases? Okay, I'm on question number 9. Is it visible, Zaid? Then we'll move on to
Mm-hmm.
regression. Is this question visible?
Mm-hmm.
Okay. So he has given, I'll take on the question onto our board.
It seems like a no. It seems like a decreasing variable, but not anymore.
Yes. Okay.
I don't think there's any correlation since it seems like all over the place.
Yes. How does the fuel consumption of a car change as its speed increases? Here are the data for a British Ford EcoSport. Speed is measured in kilometers per hour, and the fuel consumption is measured in liters of gasoline used per 100 kilometers traveled. Okay. So what I'll do, I'll notice the speed, which is the exploratory variable, and which is the response variable. Speed is the exploratory variable. Yes or no?
Yeah.
Yeah. And the fuel, and the fuel is the response variable. Yes.
Yeah.
So this is the response variable. This one is the response. So exploratory variable will be on to the x. Uh, Exploratory variable, that's the speed. Okay. And next on the y will be the fuel. Okay. So speed is from, I'll mark it here 0, 10, 20, like this 30. See, the graph will be very big. 50,
Mm-hmm.
60, 70. What I'll do, I'll keep it till 70 and 3. Then we'll go further also. You have to go till 80, 90, 100, 110, 120, 130, 140, and 150.
Mm-hmm.
Okay.
Yeah.
So for 10, the fuel used per 100 kilometer, it was 21. So it will start, for example, 0, it's 5, 10, 15, 20, 25, 30. Okay. Okay. So for 10 speed, for the speed of 10, it was giving an average of 21 here.
Mm-hmm.
For 20, it was giving 13. So it would be for suppose year. For 30, it was giving 10. It will be year. For 40, it is giving 8. It will be somewhat year. For 50, it is giving 7. For 60, it is giving 5.90. Okay, then 630. 630 for 70, 630.
Mm-hmm.
Okay, 630 will be a small gauge here. 30. Okay, then 695 for 80. Okay, then for 90, it is giving 7. It is increasing a bit. 7. So what I'll do, I'll plot exact dots according to it. It's getting jumbled.
Wait, can you give me a minute? I need to go to the bathroom.
Yes, yes, yes. You may.
Okay, I'm back.
Okay. So you can see that I have plotted the dots. Okay, so I have scaled very less here on the y-axis. So it is, for example, it is not somewhat clear in this part, but you can see it is a negative correlation. Yes or no, Zaid? What it
Yeah.
is, what the strength of correlation is, we need to calculate by the formula of R. So we will do the calculate the strength for this example. Strength here. Use the formula of R. What's the formula of R? R equals to, we'll do one example here, so the things will be very clear. It is summation of 1 upon n minus 1, summation of xi minus x upon standard deviation of x into yi minus y upon standard deviation of y. Yes or no?
Mm-hmm.
So what you will do, first of all, calculate the mean of the speed data. Mean of the speed data, then mean of this, then he has not given here. It will become a very tedious task. I'll suggest you to do it in homework. Will you?
Mm-hmm.
Yes. So just what you will do, calculate the standard deviation of this column and the mean of this column. We can do it easily in Python by entering the things. We can easily do it in Python. It's very easy to do it in Python to calculate the mean as well as the standard deviation. Shall I show you how to do it?
Mm-hmm.
Okay, so we'll see how Python does this. It's very interesting thing, by the way. It is a very easy task. Just you have to load the things there. So we'll somewhat see in the next class, I think, because we have, or shall we do it in this class? What you suggest, Zaid?
We're doing this class.
Okay, chalo, come on. We'll do it in this class. I've opened the Python. Okay,
Python? What?
Python. Yes. But just for calculating the mean and that, 10 to, it is to 150, 10 to 150. So what I'll do, so I'll make a list, x equals to, it is 10, comma, 20, comma, 30, comma, 40, comma, 50, comma, 60, 70, comma, 80, comma, 90, comma, 100, comma, 110, comma, 120, comma, 130, comma, 140, comma, 150. Okay, so I'll load it. So it is import
Mm-hmm.
by as np. So I'll get np dot mean, x dot mean. What I'll do, import as to td dot series. So what I'll do is select x equals to, this is our x variable. So x is this, our data on the x variables. Okay, so x dot mean. So it's 80, mean is 80, and x dot std to get the standard deviation. Okay, so for see how generous and quick he gives us the answer. The mean for the x is 80. Then I'll write it here. It will be sx will be 80, and sorry, it is mean. I've written standard deviation. Sorry, it's mean. Is x bar means here we are denoting it by x, and the standard deviation is around what it's around 44.72. 44.72. Okay, 44.72. That's the thing. Okay, so we'll load y also. We'll load y also. Okay, it's what I'll do one thing. Mm, will this be copied here? What I'll do? Y equals to I first I'll load this in the list. Okay. I'll end this list. Same thing here. Okay. So I'll load this in data frame. What I'll do, I'll make a data frame of x and y. So pd dot data frame of x comma y. See, x comma y, so x, x and y, x comma y. So it is clear. See there's the same table that we were looking here onto here. I have load this table here. Yes or no? Just the
Mm-hmm.
thing is that uh, I'll load this as df data frame. See df. When I'll say df. See the same thing it's here. Yes or no? Okay. So what I'll do, calculate the correlation. So I'll df dot directly see Python. How does it do? What is the correlation? It is 1.0. What it is?
1.0.
Wait. He has not taken as the index. Wait a minute. He is just relating it. Just a minute. X comma y. X is this. Is this. Just a minute. Okay, done. See,
Mm-hmm.
see, this is the data frame that we had wrote. Okay, so now we'll calculate the correlation. See, this column is giving the correlation between speed versus speed. So speed versus speed, when we calculate the correlation with the same column, it is always one. But you can see what is the correlation between speed and fuel. How much it is, 8?
Speed and fuel, it's a negative. The fuel is it's just a negative correlation.
Yes, no, that's the thing I want to explain you. That's good. So it has come. What I'll do, I'll take this thing, not data.
Seems like a weak correlation, though.
Correct. Weak correlation. So what I'll do. So what we have done, calculated the correlation using Python. Calculated the correlation using Python. Yes or no? So what we have seen here, Python in this, he gives speed versus speed. Correlation of speed with the column of speed. When there is two same columns and same entries, the correlation is always one. So in these two entries, he is giving speed versus speed and fuel versus fuel. But we don't need this because every time its correlation is one, the important is this. See, speed versus fuel, you take speed versus fuel or fuel versus speed. We have seen whether it be X versus Y or Y versus X. Does the correlation changes? The answer is no. The correlation does not change. So the correlation is minus 0.171. Minus 0.171. So it is weak negative correlation. Did you got that, Zay? How to calculate it and all?
Yeah,
Yes.
yeah, yeah.
That was interesting. Okay, so
Mm-hmm.
okay. So that's he has one more question here. Do muscles burn energy? Can you read this question? I'll drink water, some water. This one. Just read it. We'll do one more. So I'm back there. Okay, so you have seen that do muscles burn energy? So metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. We have data on the lean body mass and resting metabolic rate for 12 women who are subjects in a study of dieting. Lean body mass gives in kilograms is a person weighs, leaving out all fat. Metabolic rate is measured in calories burned per 24 hours. So see, this is given the things with the data here. Okay, so we can see the mass and the rate. Okay, make a scatter plot to display the relationship between lean body mass and metabolic rate. Describe the relationship between lean body mass and metabolic rate. So first we have to what, make a scatter plot. Okay, so this is for homework. You just draw the scatter plot and do these two questions. Is it clear there?
Yeah.
Okay, so we'll move down on to our next topic for today. That's one more important topic that has many subdivisions in it. Okay, that's the least square regression.
Yes. Mm-hmm.
This chapter 3, unit 2. We are on unit, again it's unit 2, in which chapter we were on 3. Okay, and in that we are on 3.2. So what it is, least square regression. Least square regression. Okay. So what is least square regression? I'll just give you an, what you might say, layman definition. As it's like was, we have seen that these, for example, this is a scatter plot. Okay, so now there can be drawn multiple lines, yes or no? And in on that multiple lines, different dots will fall, yes or no?
Mm-hmm.
And if I tell you that I have to draw only one line representing these all dot plots, representing these all dot plots. So what can we do? What can we do? That we can do simply that if, for suppose, I'll make the dot plots here. Okay. So what I'll do, the maximum point that comes on the line, I'll make here. This is one line. This is another line. Then this is one another line. Okay. And then this is one another line. Which line has more dots on it? This one? Yes or no?
Yeah.
Yeah. So can I say, can I consider this line as regression? No. Why no? Because there are many points. One, two, for suppose this is a point two, for suppose this is a point three, for four and five, for suppose six. There are many points that are not on these lines, but there are many points that are not on this line, but they are on the other lines. So can we take as regression? No. Why no? Because we can miss this observation. We can miss this observation from our data, and missing the data is very harmful. So what I'll do, least square regression means, what does it do? Calculate the shortest distance between the line and the point. For suppose I'll draw this line. Okay, this shortest distance from this point is this. So this line will be the perfect because all the
Mm-hmm.
points are equidistant from this point. So what we'll see in the example, see, calculate the, make predictions about the regression line, keeping in mind the dangers of extrapolation. Okay, regression line. A regression line is a line that models how a response variable y changes as the explanatory variable x changes. So he is telling that we need to draw for this scatter plot, we need to draw a line, and you know the equation of a line is y equals to mx plus c. Yes or no?
Yeah.
Okay. When this is x is explanatory variable and y is response variable. When we'll enter the value of x, we'll get the value of y. So now what
Mm-hmm.
is m? M is the slope. In mathematics, it is known as the slope, and c is the y-intercept. Y-intercept means where the line is intersecting. For suppose here this line of the dot plot is intersecting is at 2. So this will become y equals to mx plus 2. And now what is the slope? Slope m equals to tan theta. You have studied upon trigonometry, yes or no?
Mm-hmm.
Huh,
No, I
so
mean, I'm only, no,
you have not studied trigonometry?
nope.
Okay, no, no. Okay, so I'll erase this. So what is the slope? I'll generally explain you with an layman example. So it measures that how much inclined is this line. For suppose this inclined line is about 2. This inclination, we describe it as the inclination is 2 units. Okay, so this
Mm-hmm.
m will become, I'll take 3. I'll take 3, for example, 3. So this will become 3. So this line will become y equals to 3x plus 2. So did you get it? What is m and c? M and c.
Mm-hmm.
M is generally the inclination, which is described in numbers, and c is the intercept. The intercept that is on the y-axis means it too. For example, this is the line. For example, this is the line, and I am telling that inclination is around 4. So what will be the equation of the line? I'll do it downside. Wait. For suppose this is the line. This is the line for our residual plots. For this, the residual plots are like this. So I've drawn a line like this. Okay, I'm telling that inclination is 4. Okay, means m is equals to 4. Okay, now what will be the c? Is
Mm-hmm.
this line is intersecting on the y-axis? If I
No, it's
no, no,
just
I
zero.
extend the line. For suppose for suppose it is minus 3. So what will be the value of c? Minus 3. So what will be the equation become? Y equals to mx plus c. So it will be y equals to, what is m? 4 into x plus what is c? Minus 3. So it will become 4x plus minus 3. So y equals to 4x minus 3. Did you get that? How an equation of line is represent? Any linear
Mm-hmm.
equation, I'll write it down here. Any linear equation. What does linear equation means? That I am writing here y equals to mx plus c. The degree of
Mm-hmm.
this exploratory variable and the response variable is 1. So this is linear equation in two variables. In two variables means we have two variable data, two variable categorical or numerical data. That's y and x. Two variable always represents a straight line. Always represents a straight line. This is the thing. A straight line means y equals to mx
Mm-hmm.
plus c will always represent a straight line. Did you got that, Zaid?
Yeah.
So for suppose if there are what you'll say 2 to 3 lines for suppose here in this, okay, we'll go with one only. Okay, so it is a regression line. Here he has given that in this form y cap equals to a plus bx. Now again this b, it is coming with x, so this will be considered as m, that's known as slope. Okay, and this a will be the y-intercept. Okay, the things are only changing, the way of writing is changing. He's writing the y-intercepts first and then the slope with x. So the term, the coefficient or the constant that comes with x is always the slope, the inclination, and the thing that doesn't comes with anything, that's a, is always the y-intercept. Is it clear, Zaid?
Mm-hmm.
I'll think that I'll explain you this again tomorrow also in the morning class, so it will be more clear and I'll be more slow and more clear tomorrow. Okay. So what I
Yeah.
I
Okay.
think we shall do 1 to 2 sums of this and start this topic tomorrow. So what I'll do, okay,
All right.
okay. So come on, answer this question. Come on, read it and answer this question.
B.
B. Okay, I'll just read it. The scatter plot shows reading test scores, again IQ test scores for 14 fifth 40 14 fifth grade children, which effect does point at IQ equals to 124 and reading score equals to 10 have on correlation? What effect does it makes the correlation closer to 0 but still positive? uh, IQ equals to 124.
Wait, what? Wait, there's 124. Uh,
If I'll
I think
add
it
a
makes
point,
it. Oh yeah, wait, I find it. Yeah.
if I'll add a point for IQ
124.
as 124 at score 10, means the score is 10 here. What I'll do, I'll take this data on our board so it will be more clear for you. I'll explain you the question also. These questions can come in the test.
If we add it, I think it's going to be more closer to 0, but still positive.
See what will happen here. Uh, we have
It's going to be more positive.
correct
It's
at
going to be
10.
closer to
We'll add
0.
124. This is the point here. Okay.
Yeah.
So see now the line is going here. Okay. It is far away, so it will be more closer to 0. Yes or no?
0. Yeah.
Okay.
Yeah,
And
that's
it
what I
will be
meant.
still positive.
It'll be closer
And it will
to
be still
0.
positive.
Yeah.
Yes. Okay.
Yeah, so it's
Why it is
B
going to? It will be closer to 0 because it is
because it's an
far away.
outlier,
It is far away from it. Okay.
an outlier.
Yes. 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 Okay. Okay. Next question. We'll go back. Okay. Now answer this question. 32-1. What he's telling, if the woman always married a man who were 2 years older than themselves, what be the correlation between the ages of husband and wife? For example, I'll take this uh, age of wife, age of girl, and age of men. Age of men. Okay. For suppose I'll start it from 2, 4, 2 not. I'll start from 20, 21, 22, 23, 24, and 25. We'll do for this, and it will start from 20, 21, 22, 23, 24, and 25. I'll require 26 also and 27 also. Okay, for a 20-year-old girl, he'll marry a 22-old boy. Yes or no? For a 21,
Yeah.
he'll marry 23. For a 22, he'll marry 24. For a 23, he'll marry 25. This
It
is a
would
simple
just be
question.
one.
Yes, it will be a straight positive relation, and the correlation R will be 1. Very good, good, good.
Yeah.
Next, come on. Next, you see this. Come on, read this 31 question.
It's a negative correlation.
Negative correlation. Okay.
Uh, the weight gets lighter if you use less gas.
Wait a minute. I'll read the question. The following graph plot the glass gas mileage in miles per gallon of various cars from the same model year versus the
Oh yeah,
weight.
wait. So it's E. Japanese cars tend to get worse gas mileage than the other cars.
Correct, correct. Okay. Okay, now this 30th one.
Mm, maybe.
In a scatter plot of the average
Mm,
price of a barrel of oil and the average retail price of a gallon of gas, you expect to see very little association. See what is telling that.
I think it's E.
Ah, yes, it will be yes. It will be yes.
Yeah.
Okay, in a scatter plot of average price of a barrel, for example, pen is not working again. What is So for suppose this is the average price and of the barrel of oil and the average retail price. Average retail price. So if the average price will increase, for suppose I am buying a barrel for 20, I'll sell it for 30. Yes or no? If I'm buying a barrel for
Mhm.
40, I'll sell it for 50. Uh, 20, I'll sell it for 30. Wait a minute. If I'm buying for 20, I'll sell it for 30. If I'm buying for 40, I'll sell it for 50. If I'm buying for 60, I'll sell it for a more higher price. As the average buying price, cost price increases, selling price will increase or not? Yes or no? Yes. So it will be a positive correlation,
Strong
strong positive
positive. Yeah.
association. Yes.
Mm-hmm.
Okay. Now the next 29th one, try it on your own. Come on.
I'm pretty sure it's the price of the oil.
Yes. You have data from many years on the average price of a barrel oil and the average retail price of a gallon of unleaded regular gas oil. If you want to see how well the price of oil predicts the price of gas, then you should make a scatter plot which has the explanatory variable. Okay, we need to see the relation between the see how well the price of oil predicts the price of gas. So we'll plot the thing between. You should make a scatter plot with dash as explanatory variable. Either oil price or oil gas. It will be D. Yes or no, Zaid? I've told you the explanatory variable and the response variable does not matter when you are plotting a scatter plot. Yes or no, Zaid?
Oh yeah, it's D.
Okay, it's a D. Okay. Oh, then you can try different sums from here. And in the next lecture,
Mm-hmm.
that's for tomorrow, for you tomorrow. At what timing shall I take for tomorrow? I forgot.
Just take it at
6 a.m. or 6:30 a.m.
mm, any 6 a.m.
Okay.
6:30 a.m.
Okay, 6:30 a.m. I'll take. Okay, 6:30 a.m. I'll take your
Mm,
class. 6:30 a.m. Okay,
All
right.
right.
6:30, I take it.
Mm-hmm.
Okay, so you can practice those sums till then. Okay, so we'll stop and we'll start with the next regression line in the least square regression in the next class. Is it okay, Zaid? Okay, so you practice. Good night. Assalamu alaikum.
Night. Assalamu alaikum. Yeah.
Bye.